Hello, good day to everybody. Okay, this is also a request from different assessment center because this is the one that that was given by Tesla to assemble and to make it work. So, but some other trainers do not know the principles of this project, which is the night switch project. So this circuit, uh, when daylight, the lamp, which is the extension lamp, when you connect it and plug it in the outlet, the circuit will energize. But when daylight, the lamp will not turn on. So it means no light there. It is off. So when at night, it will begin to turn on and the light goes on. Okay, let's begin the explanation how it works and the flow of electric current. So we have here a circuit which is night switch circuit. So the component inside the circuit is the main plug, the outlet, the extension lamp, the triac, triac. I didn't write the triac. This is triac. This is also a 4 diode, but it is not a bridge type. No. We have the 4 diode there. It is a bridge type diodes. We have a transistor here. We have LDR. What is an LDR? It is a light dependent resistor. We have series of resistor here where we have a diode. We have a potentiometer or trimmer or pot potentiometer. We have a capacitor here. Okay, so let's begin the explanation of this circuit. So first, when you plug this to the AC outlet, the AC voltage here will flow there in the series of resistors there. Then it trims the AC voltage. What do I mean trim? It make it low voltage here. No, the flowing of AC will be trimmed. So the voltage here is very low because the voltage here will go to the gate of this SCR. So then the voltage here will go to the bridge type diode, and the positive side herein we have here the transistor, small transistor, which is the load side of this bridge type. Load side means it will consume energy or voltage given by this uh, bridge type. So, okay, the voltage here will go here, and if it is an AC, the AC half or 180 degree of the cycle, the diode, uh, the two diode will begin to be an conductor, so the voltage will go to the gate. Okay, so when the voltage, because of it is AC, the changing of the voltage here will be sometimes negative, and this one will conduct. That is also the gate or the trigger gate voltage. Okay, so when this transistor operates, no, it will become the load of this uh, bridge type load. It means it's consumed current, so the voltage here will be more lower than the expecting voltage to trigger the gate. So it will divide, no, it will divide because it is the load and this is the load. Why is it load? Because it will function. Okay, how will it function? The LDR is a light dependent resistor. When when the light passes through or sense the light, the resistor here will have a resistance, lower resistance. So the the voltage here, which is the AC, will rectify the single diode, and the DC voltage, which is the positive side, will go here. No? So it will be flow to the base of the transistor, and the transistor will have a uh, base voltage and negative side of this bridge type, so it will forward bias. So when it is forward, the base and the emitter, the connection, the switch will start to turn on the transistor. The transistor will switch to on. So this is the load side. So it consumes electric current or energy because it is functioning, it is working. So this is the load. So the voltage here becomes smaller because it consumes the voltage here, here. So it lowers the voltage here, passing to this diode to trigger the triac. So so when it is lower, the gate trigger voltage will be lower. It will not get the thresholds or the switching point. The switching point of the gate to to switch the triac. Triac is a two 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 uh, two what is that? I'm so sorry. No? Two SCRs. Okay, two SCR. Sorry po. Two SCR. No, one direction is here and the other direction, which has a gate. No, when you look at this, the the gate voltage could be positive or negative as long as it triggers the SCR. You know, SCR, a single SCR, when you, this is like a diode, when you switch on the gate, no, when the DC, if it is SCR, when the DC begin to enter in the anode side, even you disable the gate, you will not turn off the passing of the current from anode to cathode unless the input voltage will stop. Uh, so so this one is also like that, no? But we have here the AC, no? AC here. The neutral side, AC, or one side of the AC. This one and this one. Okay. So when it is at night, when nighttime, this LDR will be infinite or open. So we have no base voltage here, and this resistor will stop operation. Why is it stop operation? Because it will cut off the base voltage from here, uh, rectified by this diode. So this will not drain the voltage from positive side to negative side because it is often not functioning, that this is disabled. This is also disabled, like disabled also. So oh so this one, this become higher because this is disabled, like a disabled, because this is not functioning. It will not consume electric, mostly electric current. Small amount of current, negligible current flow here. This time the voltage here will become high and the gate voltage will become high, and even uh, and even the threshold switching point will reach the switching point or the threshold. I'm sorry, I'm stammer because someone called me and asked me if I have lunch. Okay, let's proceed. So then, if this is positive, maybe positive side, maybe the other side will switch, and this will a connection. And if so, when changing, alternating, there the 180 degree reach this X or zero crossing point, the the SCR the SCR will no longer because the input voltage is zero, so it will cut off. Okay, then it will change. Then the trigger also become negative or positive. The negative, the other one will be the one will switch because this triac is bidirectional, unlike diac. So to to simplify, the trigger here is changing sometimes, no? So sometimes it's positive, sometimes it's negative. As long as there is a uh, trigger switch or kick switch, small switch that enable to switch on the uh, triac. So when it is switched, we have here the line 1 and line 2 open. This one also. When you plug this when it is connected, the light will turn on. Mm. You do you understand? Okay. This is in front. I did not review this, because they text me that the trainers like this to explain their assembling. Okay, so let's recap. No, so when the voltage you plug there or there, plug it here, then it trims that resistor. Oh, the resistor is the trimmer. So every resistor has a voltage drop. So when the voltage reaches this one, this is a low voltage. But when the transistor operates, because it is light or it is daytime, the resistor is has a resistance, lower resistance. The base voltage will trigger the transistor. We have a forward base to emitter voltage, and it will transistor conduction. So the the connector and the transistor and uh, the emitter will connect. So this will become the load of this bridge type diode, and it consumes a amount of energy or electric current. So the voltage here will lower. So it is in the negative side of the threshold of the gate. Threshold is the switching point. No? If the switching point voltage adjusts to threshold 3 volts or 2 volts, when it's lower, it will not reach the 2 volts. So it will not, if you have a 2 volts here in the gate and the threshold is 3 volts, this will not turn on. So when at night, this will be open. This because it depends on the light So it will not open. The base voltage mo will gone, and the transistor will become disabled. It will not consume a current because it is so. Here, that will consume also a current, current that lowers the voltage here. Negligible amount of current maybe he has. So the voltage here will rise and will go here and rectify there. If it is AC, then uh, it will reach the threshold or the switching point. Then it will switch and this will switch. So the AC here go here. So this will energize, uh, and if you plug it, this will light. So that is the explanation, simple explanation about the night switch. So the big deal here is the triac and the LDR. Okay. So thank you very much. If you have a comment, or you text me. Don't forget to subscribe, like my channel, YouTube channel, Eddie Reyes. This is Eddie Reyes. And good day. Good day. Be aware of my other blogs, like operational amplifier, logic circuits, and the classes of amplifier class A, class B, push-pull. I will explain it to you clearly at the most of my knowledge. I'm so sorry for stammering my explanation. Thank you very much. Bye-bye.